So welcome to all of you in video based IT training. In this video I'm going to cover about the dynamic routing, introduction to dynamic routing, how it is different from the static routing. As in my previous video I have discussed with you about static routing. There are a lot of advantage as well as disadvantage of static routing. If you talk about the advantage, what are the advantage, why we prefer the static routing? Easy to configure. How it is easy to configure static routing as compared to dynamic routing? In case of static routing, administrator should have the complete knowledge about each interface where that particular link is connected. So if administrator have full knowledge, had the complete topology knowledge, then it is very easy for the administrator to configure the static routing in small networks. But second, no extra resource are needed. Administrator have to finalize the path from any source to any destination. Router does not have to take any decision to choose the path. So it put very little load on the processor of the router, and it will not consume any bandwidth to update the neighbor about the new neighbors. More secure. Administrator have to choose it manually, which path is more secure as compared to another path. If we have two alternate paths, which path is more secure? So administrator have to decide on the basis of all the parameters that he considered. He can choose the best secure path. So many advantage, but it also have the disadvantage. What are the disadvantage? Very first, network changes require manual configuration. What does it mean? You have chosen this particular path or this particular route as a best route from R1 to R2 or any of the network that are connected here to. Okay. In case it become down due to any reason, you instantly have to move to the site, update a new path, that this path is down right now, so choose a new path. Okay, this have to follow this particular path to reach R1 to R2. Now this have to follow this particular path. So every change require manual reconfiguration. It will not automatically update the neighbors that there is some change in topology. Does not scale when in large topology. Second point, it's okay, it's very easy to configure this route because only 2 or 3 router, very simplistic network, so you can choose that. But what about this? So many paths to reach from this source to this destination. There are too many paths available, na? From here also we can go, from here also we can go, or router can choose the path. From here also it can go, from here also it can go. So many paths. So it becomes very difficult in a complex network to configure static routing. So by looking in complex network or enterprise network, we always prefer to have a dynamic routing. Dynamic routing means they keep exchanging their routing table with each other, that yes, I have this new path, it will intimate to the neighbor. So what are the basic requirements to route a packet from one network to another network? If this machine need to send some data from this network to this network, so what are the basic requirements at this end? What this router should know to send the packet up to this destination. So very first, it requires a destination network where the packet has to be sent. Neighbor router from which it can learn about the remote network. Who will tell me how I can reach up to that network? Okay, na? So which one is the best route? This is the best or this one is the best? So this router should be aware about how I can reach this destination via this router or this router more easily or more comfortably. all possible path to reach the destination network and then choose one best path to reach to the remote network. This router should be aware about all the things. Either this particular router should follow this path or should follow this path. First it should know about all the paths, then have to choose which one is the best path. This one is the best path or this one is the best path. Correct? Once it choose the best path, after that keep maintaining, updating routing information on all the router if there is some change in the topology. Suddenly, initially this router have chosen this path as a best path. Due to any reason this path become down. Or wait, some of the new network has been added here. So keep maintaining means updating all the neighbor router, first to this router, then to this router, then to this router. Yes, we have a new network here. 10 network here exists now. So keep maintaining, updating the routing confirmation all the router if there is some change in topology. So these are the main requirement at the source router that must know to send the data to any destination. So the dynamic routing is used to find the remote network. Dynamic routing protocol, how we can define that? That is used to find maximum number of path very first. Second, shortest path, which path is shortest path, and then choose the best path from any source to any destination. It is when protocol is used to find the remote network and keep updating routing table automatically when there is some change in the topology. So that is the basic difference between the static and dynamic routing. In static routing, administrator manually have to update the routing table of each router if there is some change in topology. But in case of dynamic routing, that work is done by the protocols. Whatever protocol we are using for the routing, they automatically keep finding the remote network, which new network comes inside the network or which older network has left due to any reason, and keep updating the routing table automatically to all the routers. How does it work? Ooh, 3 cute people. So I know one person, XYZ, and this particular person know about this. Okay, so this person know about this particular XYZ person or a department where he have some task. This person intimate this guy, yeah, I know XYZ, if you have any task send it to me or let me know. This intimate this guy, if you have any tasks let me know, I will reach you up to the XYZ. In the similar way, if we have some another, this person knows about ABC. Okay, this person directly knows the ABC. So this person intimate to this guy, okay, let me know if you have any task with the ABC. This person intimate this. So all these 3 guys keep exchanging their information. Yes, yes, yes. So in this way they keep communicating their information with each other. So now this person A knows about the ABC network, and this person, suppose for example C, knows about XYZ. So in this way they keep exchanging. Dynamic routing protocol also keep exchanging their information with each other. So basically dynamic routing protocol defined as a set of rule by the router when it communicate routing information between the neighbor routers. They always keep updating the neighbors. Yes, I know this, I know this, I know this, I know this. If you have any task, let me know. If you have any task, let me know. Okay, so in this way dynamic routing protocol works. How we can classify? There are n number of dynamic protocols. There are many number of dynamic protocols in the network nowadays. So if we take this look, very first dynamic routing, then dynamic routing is classified into two main. One is the IGP and one is the EGP. EGP stand for exterior gateway protocol, IGP stand for interior gateway protocol. Now what is this IGP and what is this EGP? That is differentiated with the help of one word that is known as autonomous system number. What is this autonomous system number? Again the question, huh? This is the autonomous system number. Is a group of router that comes under control of single administrative domain or single authority. Means EIGRP is basically used for a big enterprise network, or any of the routing protocol that you are using, that is for the big enterprise, not for the small network. There can be thousands of routers, there can be hundred of routers. So to easy management, we can divide that into the separate groups. That this particular router belong to my XYZ side, this particular router belong to my ABC side. So we can divide this router under a single administrative domain or in different groups that is handled by a single domain or single authority. So interior gateway protocol used for the routing inside the AS number, means to communicate within same AS number, to communicate between same AS number is IGP, and to communicate in different AS number is EGP. Okay. So when we are communicating within same AS number, means we are communicating between the router that comes under a single administrative domain or comes under a single authority is the IGP, and we have to communicate in different AS number, then it is the EGP. Like this example, this is the AS number 100, this is the AS number 200. So when we have to communicate between these routers, from this router to this router, this router to this router, this router to this router, anywhere within the same AS number, that is known as the IGP, interior gateway protocol. And when we have to communicate between the different AS number from 100 to 200, that is known as the exterior gateway protocol, or you can say example is BGP for that. So IGP again divided into three parts: distance vector, link state and hybrid protocol. And example of EGP is the BGP, border gateway protocol. So if we talk about the distance vector and link state protocol, routers are advertised as a distance or a direction. In the distance vector protocol, it only care about the distance and direction, does not care about other parameters. Like there are a lot of matrices that I'm going to discuss very soon. So routers are advertised as a vectors of a distance and direction. It does not take care anything about the other parameters like delay, bandwidth, load and reliability. Second point, incomplete view of network topology. It only knows about the route advertised by the neighbor. It does not have a complete topology. It only have a one single best path at one time, and generally periodic update. Okay. It does not give any intimation if due to any reason this link become down. This link become down. So it will, suppose it have some another neighbor also here. So it will only intimate at a periodic time, not regular basis. But when we compare with the link state protocol, complete view of network topology, if it is connected via this here also, via here also, okay, so this router have the complete network topology, how we can reach from here to here via this path, or however, so we can reach here. Updates are not periodic, means it will not wait for any update timer. As soon as there is some change in the topology, it instantly updates the neighbors. Yes, there is some change in topology. So link state is faster than the distance vector, because distance vector keep waiting for the update timer to update the neighbor that there is some change in the topology. But link state, as soon as some change come in the network, it instantly update the neighbors. Okay, so every protocol, either EIGRP, either OSPF or RIP, have a specific matrices. Matrix means every dynamic routing protocol use a algorithm to find path from source to destination. As soon as you configure any of the dynamic routing protocol on the router and connect it to network, it starts searching for different path from any source to any destination. And then it chooses one best path on the basis of matrices. Means it uses a specific parameter how to find out the best path from any source to any destination. Every protocol has used its own parameters, its own matrices to decide which path is best. So there are different matrices that we can use, that every protocol use to find out the path. The most common: hop count, delay, bandwidth, load, and reliability. These 5 matrices are very common metrics that different protocol use differently depending on the algorithm. So now what is this hop count, delay, bandwidth, and reliability? Hop count, number of routers from source to destination. Like, come back to on this particular slide. If we configure distance vector protocol on this network, if we configure some of the distance vector protocol on this network to reach from here to here, if you configure the distance vector, what it calculate? Okay, from here one router, two router, three router, and which is the destination. Same here also. But if you go for 1, 2, 3, 4, one here, two here, three here, and 4 here. So distance vector only choose on the base of hop count. So number of router between source to destination. Like here 1, 2, 3, 4. Where this path 1, 2, 3, 4. So these are the hop count. Number of router coming between source to destination, that is known as the hop count. Delay, travel time taken from source to destination. How much time any packet is taking from reaching from source to destination. There can be the n number of reasons that increase the delay. But some protocol also calculate the delay time, how much time it is taking to reach the packet from source to destination. Bandwidth, I think everybody familiar with that. Data carrying capacity of one link. We have 1 Mbps link from source to destination. We have 2 Mbps link from source to destination. That is the bandwidth. Load, number of activity on the network. How much activity happening on that network? I'm taking very common example. Suppose you have one internet connection. You start downloading one thing, any of the data, that can be the movie and it is will give you very high speed. But as you start downloading, you start 3, 4, 5, 6 movies or any of the data from the same internet connection, naturally the load will increase on the network and it will reduce the overall speed of the network. So means number of activity, how much activity happening on that network. And last one is the reliability, bit error rate on the link. Due to any reason, there can be the loose connection or any other reason, how much bit error rate on that particular link, how much that link is reliable to carry my data from source to destination. So these are few metrics that different protocol use to calculate best path from source to destination. And last point, administrative distance, on which router decides which path I should follow to reach from source to destination. So what is basically administrative distance? This is the measure of trustworthiness of the source of the route. Who is telling me that particular path? Suppose on the same router we have static routing also, we have EIGRP also. Now to both the protocols or both the routing methods give a specific route to the router. Now on which particular route path this router will believe? Can see here, this is the measure of trustworthiness of the source of the route. If the router learn about a destination more than one routing protocol, administrative distance is compared and the preference is given to the route with lower administrative distance. In other words, it is the believability of source of the router route. A router getting a route from which source, from which protocol? These are the different default AD. Like directly connected interface comes with a default administrative distance of 0. Static comes with 1, or you can say EIGRP default AD is 90, IGRP default AD is 100. Nowadays this is not work. We are not working on the IGRP. Cisco does not supporting IGRP. And OSPF 110, RIP 120. So these are the default matrices. So for default administrative distance of each of the routing protocol by default. Like you can see here, when we configure this one, like D stand for EIGRP. So you can see here, look here, 90 means we have configured EIGRP here. So in the similar way you can say EIGRP internal network is 90. So in this way, these are the different parameters that every protocol use to choose best path. And in this way, as compared to static routing, dynamic routing have many more benefits. If there is some change in the topology, they automatically update its neighbor. So thank you for watching the video.